Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 11G. My name is Alesha Mullah, and I would be your moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026 in Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, and the virtual event is being held from 9th to 11th April 2026 via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chairs for today's session. Our first chair for today is Professor Bobby Eclairin. He is an associate professor at Mariano Marcos State University in the Philippines. With over 22 years of experience in higher education and information technology, he specializes in applied computing and interdisciplinary research. His interests include e-learning and instructional systems, agricultural informatics, environmental monitoring, and image processing and artificial intelligence. Welcome, sir. I would like to request you to please say a few words.
Hello, am I audible?
Yes, you are.
Okay, so good afternoon, everyone. I am Bobby Eclarin from the Philippines. Welcome to the third day of the 11th International Conference on Information and Communication Technology for Intelligent Systems. This is happening right now via Zoom. And personally, I am inspired that this gathering brings together leading researchers, innovators, and practitioners to share breakthroughs that will shape the future of intelligent systems. So we are expecting innovative researchers to be presented today. So I would like to congratulate you in advance. Thank you.
Thank you, sir. Our next chair for today is Dr. Shalini Puri. She's an associate professor in the Department of Information Technology at Manipal University in Jaipur, India. She has 20 years of teaching experience and 11 years of research expertise. Her research interests include machine learning, image processing, pattern recognition, and artificial intelligence. Welcome, ma'am. I request you to please say a few words.
Yeah, thank you so much for the invitation. And this is a very good platform for all the presenters and research scholars and other members. Thank you very much for the invitation. All the best for all the participants.
Thank you, ma'am. Without any further ado, let's begin with today's presentations. First up, we have Hema Malini Srinanjeevi, who will be presenting a multimodal knowledge-driven framework for urban scene summarization. You may now begin your presentation.
Good morning to all. This is Hema Malini from Sastra Deemed University, and I'm here to present the paper on multimodal knowledge-driven framework for urban scene summarization. Is my presentation visible to you all?
Yes, it is.
Okay, ma'am. Thank you. My co-authors are Swaminathan Arangakraman sir from Sastra, Darshini Gayatri and Sushma Sri also from Sastra Deemed University. So in the outset, I would like to highlight the abstract and challenges. So the smart cities generate a lot of data over a period of time, both audio and video data. So these data are being creating a lot of information overload. So getting some useful information from that and raising some actionable events for case of emergency situations. That is the idea of our project. So here we would like to transform the relations available in the images as well as audio or video into dynamic knowledge graph and employ language models for human readable summaries, at the same time integrating the audio cues for emergency detection and provide interpretable explanations. So in this, we are trying to perform spatial temporal relationship gathering from the available data and real-time interactions between the objects that is available in the urban environment, along with audio integration and interpretable explanations. So the literary review on observing this, we can see that although there have been so many models proposed over a period of time, there are some shortcomings of each of these systems. For example, YOLO V12, which has been used by Pandey et al., there is no explainability or audio integration. And Deep Sort, proposed by Zhu et al., they are having computationally expensive and no velocity-based relations are available. Similarly, for Zhang et al., they limit to only bounding box output, whereas Wang et al., they are not having any temporal or velocity dynamics, whereas Li et al., they are proposal, the graph neural networks, convolutional neural networks, they have very slow processing speed and high computational requirement. And the proposed system by Kumar et al., they are offering only offline processing and there is no knowledge graph integration, whereas static graphs, that is a limitation of Smith et al. And Chen, their proposed system is requiring high computational cost and large training data, but no tracking is available. Same way, there is no multi-class categorization and no natural language explanation for the system proposed by Das et al. Rao et al., they are having low accuracy in crowded scene environment. So based on all of these, we got inspired and we could identify the critical limitations available in the current approach, that there is lack of motion-aware relational context, and it is either restricted to only single modality bias, either vision only or audio only, and the black box output, there is no scene explanation, and the knowledge is static as well. So here, our proposed system, we are proposing the idea of motion-aware relational context with multimodal integration, utilizing the concept of dynamic graph updates, thereby generating explainable summaries also. So the research gap that we are trying to rectify is the existing systems rely on low-level visual features and independent object detection, whereas failing to capture contextual relationships and temporal continuity. So our contribution would rectify these by utilizing the semantic depth gaps through structured reasoning and natural language recognition. So in the final step, we are going to generate actually shallow summaries, which rectify the shallow summaries which are present in the current systems and present with the detailed summaries. So the system architecture, we are performing input processing, object tracking, velocity extraction, audio classification, knowledge graph, and text generation. So this is the architecture diagram. To start with, we take inputs from the video frames and stereo audio. And in the perception stage, we use the YAMNet and YOLO V11 X and with byte track to identify the tracks. And from this, we detect the relations with the help of these knowledge-based rules, the triplets. And from this, we identify the events. And these events are then converted into summaries with the help of the 5-3 meaning system. So here, after in the output stage, we are doing a visualization as well. And the output stream is semantic dynamic knowledge graph. So the proposed system specification has been listed here. So for various stages of perception, we have used the, that is a perception, we have used OpenCV, FFmpeg, and YAMNet. And tracking, we have used YOLO V11X and the byte track. Relations have been gathered with the help of rule-based motion heuristics and DKG update with the help of network X diagram, event detection with pattern rules and VF2, and summarization with the 5-3 mini model, visualization with the help of matplotlib and 5is, and deployment with the help of Candle. So the proposed system modules already we have discussed, and during the module level parameters settings have been specified here. And the data set details, we have used 2 data sets, that is TAU Urban Audiovisual Scenes 2021 and MA VAD data sets. Out of this, the TAU data set is a multimodal data set combination of audio and synchronized video recordings. The key features are synchronized audio-video streams with multiple urban field categories, and manual annotation for events also is available. And it is done in diverse weather and the lighting conditions. MVVAD data set is also audiovisual synchronization data set featuring emergency events. So the key features here is the emergency events are present and audiovisual synchronization, real world urban scenarios and varied recording conditions. So the results we are presenting here, this is from the MAVRD data set that is one of the files from the MAVAD data set where the semantic dynamic knowledge graph has been presented here. So as you can see, there are various objects identified and how many, what is the kind of spatial relationships. Also the movement of the particular object, same object has also been identified, and the edges represent the relationship between each of these objects. This is the annotated video, and the summary generated by this proposed system. This is for the other output PAU data set file. For this, the dynamic knowledge graph construction, the annotated video, and the scene summary. And we tested this system on another random WhatsApp video file for which consisted of an ambulance data. So here for this, we have generated the critical predicates, and we can see the annotated data with generated summary. And you can see that it has identified the emergency details from here. So to evaluate the results, we have used so many metrics like AV fusion, perception and tracking. For each of these modules, the metrics we have used like emergency token ratio, AV mode activation, velocity smoothness, all these are the metrics we have used. Nearly some 17 metrics we have used. And the evaluation of the proposed system, we can see on, for example, emergency token ratio for MAVAD file and the PAU data set is 0, whereas for the test data, it has been identified as 0.3976. And AV mode for these, actually, the data sets provide separate files. So in case of test data, based on the input from the siren and the ambulance data, this has been given as 1. Similarly, for mean detection, velocity smoothness, for all of these, we can see that our system has identified, for example, siren emergency co-occurrence has been clearly identified in case of the test data, which consisted of the ambulance. No coverage, everything is recorded here. And similarly, the throughput content XPS also has been given over here. So in conclusion, we can see that our system has identified the relational reasoning, multimodal integration, explainability, and temporal consistency with context-aware intelligence. Our system has identified nearly a very good summary for the given input audio and video data. These are our references. Thank you. So any queries?
Hello.
Yes, sir. Good morning, sir.
Good afternoon. Okay, so you have introduced this DKG, the
Yes, sir.
destructural entities. Yes. How does DKG handle scalability when applied to large-scale urban surveillance networks?
Okay, real-time
So,
networks.
what are
Yeah.
your strategies to mitigate this complexity?
Right now, we have worked only with the data sets. We are planning to extend this in the future system. Maybe we will try to integrate with the advancements of our proposed systems. Sir.
Okay, so well, actually, that's one of my recommendations to consider extending the
Sure,
evaluation to real-world smart city applications.
Sure,
Okay.
sir.
Thank you, and have a good day.
Thank you, sir.
Yes, I want to ask.
That's all for me.
Yeah.
Thank
Yes,
you.
ma'am. Yes, ma'am. Good afternoon, ma'am.
Yeah, good afternoon. In fact, good morning.
Good morning, ma'am.
Yeah, good morning. So, I just want to ask that could you elaborate on your fusion strategy? Is it early fusion, late fusion, or hybrid?
Fusion strategy, we are integrating the components of video recognition. That is, from the video, we are recognizing the tracks, and then we are integrating it with the audio data. We do it in the pipeline. It is right away available.
But anyhow, like it can be categorized in the early or late. I mean, these fusion strategies actually exist. So, I mean, which your work comes into which category? Early, late,
We
or
can say
hybrid, or yeah,
early fusion only, ma'am. Early fusion, not
early
late
fusion.
fusion.
Okay, because you can elaborate more on, on the early fusion, and then you can include something on that in the future as well.
Yes, ma'am.
And
Sure, ma'am.
I also want to ask, did you conduct any user studies to validate the interpretability and usefulness of your summaries?
Not yet, ma'am. We haven't done research.
So,
So
okay,
that will be a nice thing to consider for the next step, ma'am.
okay. Thank you. That's from my side.
Thank you, ma'am. Thank you.
All right. Our next presentation for today will be by Lakshmi Sagar S, who will be presenting a review on large language models in engineering. You may now begin your presentation.
Just a minute, ma'am. I'm facing some issue with the camera. Just a minute. Yeah, it's good. So, good morning to one and all in this. I'm just a student from Madanpalli Institute of Technology and Science, and I have co-authored the paper Review on Large Language Models in Research Engineering. I will show you the presentation just. Am I audible right now?
Yes, you are.
Okay, I will share the presentation. So this is the presentation of our paper, A Review on Large Language Models in Engineering. It is co-authored by Nitin Gattapagari, me and my other friends, and my guide Praveen Kumar Raini. So on the outline, where we have introduction, LLMs in engineering and challenges and conclusion and references, the outline of the paper, of the review paper. On this introduction, we just discuss about the basic where the LLMs came into picture in the engineering fields, like for in programming generation, problem solving, intelligent tutoring, technical writing, and simulation supports. Like from the late 2022 and early 2023, these LLMs use has been surged and it has been widely used by many students because of the ease and efficient use of the and performance of these LLMs. And these are used in various purposes like code generation, simulation tools, step-by-step derivations, tutorings, documentation purposes, and so on. We'll discuss about that in the next slides. Yes, this is just a basic walkthrough of these of the things we will be discussing in the paper. But I will just go through what we will discuss on the benefits of the LLMs. We can see on-demand on-demand explanations, and it can give, if you have a phone and internet, you can access anytime the LLM and get step-by-step explanations, and it can bridges the gap between the concept and the implementation of your paper, and it can reduce the and it can reduce the time spent. And coming to the challenges, we can see this is a risk of passive knowledge. Sorry, I'm facing some issues with the screen sharing. Could you just let me 5 minutes time?
All right. In that case, we'll move on to the next presentation and we'll circle back to you.
Yeah, thank you so much.
All right. 1 second. So our next presentation for today will be by Maharshi Bhomik, who will be presenting Integrated AI System for Suspicious Activity Detection in Public Surveillance. You may now begin your presentation.
Hello, am I audible?
Yes, you are.
Good morning, everyone. I am Maharshi Bhaumik. I am a fourth year BTech student. I am studying at PES University, India. Today, I am going to present my idea. Let me share my screen. Yes. My co-authors are Rishabh Kumar Agrawal, Meera Abbas Hussain, and Sachin Kohli, and our mentor is Dr. Vaishali Shinde. So our problem statement is like integrated AI system for behavior analysis and object detection in public surveillance. Basically, the problem statement says like we have witnessed a huge increase in the crime rate in recent time in India. So the existing solution is like we have CCTV cameras, which are not efficient for detecting any kind of suspicious activity. Uh, so it is just used for like a proof for any crime. So we are here to uh, fill the research gap in that uh, by uh, by implementing a AI model in which various suspicious activities through AI models. Uh, there are few past works here on this particular topic that are detection of criminal activity using deep learning, enhancing public safety, AI powered intelligence surveillance, detecting criminal activities from CCTV by using object detection and machine learning algorithms. But most of these past works, they are highly dependent on like that particular data sets of any activity recognition, or like particularly on one particular model like object detection. If any harmful object like weapons are detected, then it will detect activity as suspicious. But that might not be the case all time. Having a weapon is always lead to unsuspicious activity. So here we are. Here is the architecture that we have designed, where we have implemented various models like object detection, facial expression, a bleep, and pose estimation, with the help of which it gives a good contextual information about the whole scene, about the whole situation. Uh, for example, now I will be explaining each and every models that we have used. First of all, we have the object detection. We are using YOLO V8N for object detection. It is pre-trained on COCO dataset. And then we have the facial expression recognition. We are using a deep face model, which is pre-trained on FER 2013. It is comprised of like seven different emotions, which is anger, disgust, fear, happy, sad, surprise, and neutral. And then we have pose estimation. This gives like the posture of each and every person there in a particular frame. And then we have the bleep. Like bleep is used for image captioning. It gives the contextual analysis of each and every frame that is being analyzed. So if we go back to the architecture, we can see that like from uh, we extract each and every frame from a particular video, and we pass all the frames to all the four models that we have designed: the object detection, facial expression, and bleep and pose estimation. uh, the results from each of the model is taken and forwarded to the decision layer. And decision layer is an LLM, which basically takes the results of each of the model and assigns a suspicious score. If the if the suspicious score is above some threshold, then we can detect it as a suspicious activity, or we can mark it as any criminal offense. So so this is like the results of each and every models that we have designed. The object detection, the accuracy matrix is mapped at the rate 0.5. It's the score is 0.72. The pose estimation is 0.81. Facial expression accuracy is 0.76. Interaction is 0.484, and the decision layer accuracy, the F1 score, is 0.79. And this is a simulation, if I'm allowed to share like how our model works. Hello. Here you can see that in the decision analysis, it is given as a suspicious. Uh, yeah, that's it from my side.
Yeah, nice presentation. So, I want to ask, given the increasing concerns around surveillance, how does your system address privacy, data protection, and ethical use, especially in the large-scale deployments?
Mm, Actually, we haven't means thought of in these topics yet. Actually, like privacy issues, I don't. Uh, Sorry, but I am not aware of this. Like we haven't discussed it. Yes.
Okay, this is a primary concern whenever you're going for the intelligence systems. And secondly, you have said that suspicious behavior. So, how does your system define and adapt to varying notions of suspicious activities across different environments, say airports, streets, or public events?
We are using bleep as a contextual analysis for the contextual analysis. Like bleep does an image captioning of what all events are happening in a particular frame. So it sends the whole context to the decision layer, and on based on the whole context, it evaluates all the results from other models, just such as object detection, facial expression, and pose estimation. On basis of that, basis of the contextual analysis, it gives an suspicious score. It assigns a suspicious score. Thus, if a suspicious score is above the threshold, then then it marks the particular frame as suspicious.
Okay, thank you.
All right. Good afternoon once again.
Good afternoon.
I agree with my fellow session chair with regards to the ethical guidelines and privacy regulations. No? So in the future, you should also consider that one, emphasize compliance with privacy and ethical guidelines. So, in addition to detection accuracy, consider evaluating system performance also in terms of response time, resource efficiency, and of course, user trust. That's my recommendation.
Thanks. Answering to the privacy question, I feel like we are implementing this on a CCTV cameras. So we are, so privacy, I feel like it should not be a concern. If I'm not wrong, I don't know.
Look, sir, ultimately, our solution is not hampering the privacy. It's just integrating a model into the cameras, and whatever the user is doing is not exactly invading the privacy at all. We just want to find at that place, at that point of time, what crime can happen and how to stop it. So because the only thing we're doing is we want to integrate a model into the cameras.
Okay, thank you for that information. Okay, that would be all from my side. Thank you.
Thank you, sir. Thank you.
All right. Before we proceed further, I would just like to check with Lakshmi if they are ready to present now.
Yes, ma'am, I'm ready to present. Are you audible, ma'am?
No, I'm so sorry. I was talking to Lakshmi Sagar. Are we ready to present?
Lakshmi, sir. Okay.
You're actually inaudible. Okay, I think we'll move on to the next presentation. We'll come back to you. So just give me a second. All right, so next we'll have Ravina Osier Sibayan, who will be presenting Leveraging AI for Customer Insights in Oman Digital Marketing. You may now begin your presentation.
Good morning, good afternoon, good evening to everyone. Okay, so I will just share my screen. I'm having a problem with sharing the screen.
All right, no worries. We can come back to you later. We'll move on to the next presentation.
I will just leave for the meeting, and then because the Zooms and I need to reopen the Zoom.
Yeah, of course. No worries.
Thank you.
All right, so let's move on to the next presentation. Next, we'll have Maria George Anthraper, who will be presenting MalVIT, malware classification using vision transformers with robustness analysis via obfuscation. Maria, you may now begin.
Right. Hi, I'll just share my screen. Yeah, is it visible?
Yes, it is.
Okay. Hello, everyone. I'm Maria, and I'm here along with my co-authors Kusuma and Sinchana to present our work, MalVIT, malware classification using vision transformers with robustness analysis via obfuscation. So, Sinchana, you can start.
Yeah, so today we're presenting our work titled MalVIT. Malware detection is a critical problem in cybersecurity, but what makes it especially challenging today is that modern malware is no longer static, which means that attackers actively modify their code using various obfuscation techniques to evade detection. Traditional machine learning and even deep learning models often perform well on clean data, but their performance drops significantly when malware is obfuscated. So, in this work, we aim to answer a key question, which is, can we build malware classification system that is not only accurate but also robust to obfuscation? And to address this, we propose MalVIT, a vision transformer based approach that achieves 94.52% combined accuracy across both clean and obfuscated samples, evaluated over 20 malware families. And yeah, so the motivation and background for this was that malware is becoming increasingly sophisticated, and attackers use techniques like encryption and like packing and some polymorphism as well to disguise the malicious code. This makes detection a lot harder because some malware it can appear differently in many forms. Now, traditionally, deep learning models like CNNs have been used for malware classification, especially when binaries are converted into images. This visualization approach basically works by converting each byte of the malware binary into a pixel value, which forms a grayscale image. This allows us to apply computer vision techniques to malware detection. However, CNNs, which are traditionally used, they have a key limitations, which is they only rely on local receptor fields, which means that they focus on smaller regions of the image and fail to capture the global relationships. When obfuscation disrupts the structures, CNNs struggle to generalize. This is where vision transformers come in. Unlike CNN, vision transformers use self attention mechanisms, which allow them to capture longer range dependencies, understand global structure, and also be more resilient to spatial disruptions. So, to summarize, our idea is simple but powerful. We want to use vision transformers and train them in a way that explicitly improves robustness to obfuscation.
Now moving on to the architecture. To start with, we've used the malimage dataset, which is publicly available. So this dataset has about 25 malware families, but it had varying sample sizes. So to avoid class imbalance, we're working with only 20 of them. So these are available as grayscale images, but to pre-process them, to make them prepared for VIT, we have converted them into an RGB format, as well as transformed them into a size of 224 cross 224, which is standard for vision transformers. Also, vision transformers work with patches. So they've been divided into patches of size 16 cross 16, and they have been embedded into a vector representation, as well as positional encoding is also done. So these embeddings are then passed as input to the transformer encoder, which uses a multi-head attention to learn the relationships across the entire image. And then there is a classification head, which will decide which malware family it belongs to. We have also used a two-phase training strategy. So in the phase one of training, the model is only provided the clean malware sample so that it can learn the stable class discriminative features. So here we've used an Adam optimizer with cross-entropy loss. In the second phase of training, we have added we've trained the model with a combination of the clean and obfuscated samples. A lower learning rate has been used here so that it does not forget what it has learned in the first stage. Sequential fine tuning avoids that. And also catastrophic forgetting is prevented by including the original clean samples as well. We have also, because of a lack of training data that was there, we've used a k-fold training method. And we've also done on-the-fly augmentation during the training stage to avoid overfitting in the model. Now to go through the different kinds of obfuscation techniques that we used on our samples. One was high entropy region. So this is done to simulate encryption or packing. So they appear as noisy patches at the start or end of the binary image. Next is junk code insertion, where so it's basically like NOP or useless junk, which are added to disrupt how the image looks. So this appears as horizontal junk blocks throughout the image. There's also random masking, which simulates polymorphism or code reordering. So this appears as 16 cross 16 zeroed out blocks in around 25% of the image. Another one is uniform block at end, which appears as a horizontal gray region at the bottom of the image. Along with these experiments, we have also worked on the explainability of the model by using GradCam visualizations on the image to see what portions of the image contributed to the classification. All of these experiments were also conducted with CNN, as we said, so that we could compare why the VITs are able to perform better and how much accuracy improvement is observed. Going on to the results.
Yeah, coming to the results, we observe a significant improvement from phase 1 to phase 2. The clean accuracy improves from 92.3% to 95.7%, while the combined accuracy, most importantly, improves from 75.3% to 94.5%. The random mask robustness as well jumps dramatically from 36.5% to 93.5%.
Hello, I'm
This
not
shows
able
that
to,
the model is
yeah, sorry for interrupting you. I'm not able to see your presentation slides. Have you stopped it? I mean, this is a
Sorry?
black window which I can only see.
Okay, should I try sharing my screen again? Is it not visible?
Yeah, not visible yet.
Is it fine now?
Yeah, that's okay.
Okay.
like I was saying before, you can see the improvements in results on the slide. And there have been significant improvements, as you can see. This shows that the model is not just accurate, it is robust to obfuscation. And we also validate these improvements statistically using the Wilcoxon signed rank test, where we obtained a p-value less than 0.05, confirming that the improvements were significant. Going on, just to compare VITs with CNNs, while the CNN performs reasonably on clean data, it struggles under obfuscation and shows very little improvement in phase 2. While our VIT model, initially weaker under obfuscation in phase 1, but after phase 2 achieves a good accuracy of 94.5% and outperforms CNN in all metrics. Now, the question is, why does VIT perform better? It's because it uses global self-attention, captures the relationships across the entire image, and learns features that are invariant to local distortions. Whereas the CNN only relies on the local patterns and fails when those patterns are disrupted. Just to conclude, the key points were that we managed to achieve an accuracy of 94.52% by introducing a two-phase training strategy. And we now know that global attention is crucial for handling adversarial transformations because VIT outperforms CNN under obfuscation. And that training with obfuscation-aware data significantly really improves robustness. For future work, we were looking into extending to cross-data generalization, maybe exploring few-shot learning for unseen malware families, and to maybe investigate hybrid CNN and transformer models. So overall, MalVIT shows that combining vision transformers with robustness-aware training is a promising direction for malware detection in adversarial environments. Thank you.
Yeah, hello. So, my query is how well does your model generalize to 0-day or previously unseen malware families? And have you evaluated its performance in cross dataset or real-world scenarios?
So those were mentioned as future work in our paper. So currently we're working only with the malimage data set and evaluating its performance on the malware families that were available as part of the training set. But future work would include involving other data sets as well to see if the performance is maintained across that, and also employing zero-shot learning to see if it's able to generalize across malware families.
Okay. One more question. Vision transformers are known to be computationally intensive. So how does your approach balance accuracy with efficiency, especially in resource constraint or real-time security environments?
So deploying this in real time is not something that we have tackled with yet, but so I mean, the vision transformers are working pretty well in the fine-tuning stages because we are, I mean, as in the training stages, we've deployed, we've worked with and were able to achieve high accuracies, but this is not something that we have deployed yet. So that would come later too. Again, we have mentioned real-time deployment as future work.
Okay, thank you.
Hi, good afternoon.
Hi.
Yes, as to the Valdez performance against these established models like CNN, were there trade-offs? Like, for example, computational cost, interpretability. I haven't seen that in the in your comparative analysis.
I'm sorry, were you talking about the computational efficiency?
Yeah, yes, especially on the computational cost, interpretability. Of course,
So
CNN
interpret
are traditional feature-based approaches. So when you benchmark this performance against these established models, were there trade-offs?
Yes, so there are trade-offs, but this study mainly focused on how much the vision transformers were able to strictly on a accuracy part of the problem and not as much on the computational side. In terms of interpretability, as I mentioned, we have tried to include explainability in the project by visualizing what parts of the image were able to contribute to the classification using GradCam visualization. So that helped with explainability of the model.
Okay, thank you for that answer. That would be all for me.
All right. So we'll move on to the next presentation now.
Thank you.
Next, we have Jayalakshmi D, who will be presenting online product fake review identification using deep learning algorithm. You may now begin your presentation.
Good afternoon, everyone. Am I audible?
Yes, you are.
I will share my PPT. Okay, good afternoon to everyone. I am Jayalakshmi, a research scholar from SDNB Vaishnava College for Women. Today, I will be presenting my work on online product fake review identification using deep learning algorithm. Okay. The main abstract of my paper is that we are focusing on detecting the fake reviews using deep learning models. Since the AI generated reviews are being more realistic, so it is feeling we are difficult to identify the fake reviews using the traditional methods. So we have used advanced models like GCN, HGAN, CNN by LSTM, and SMVC and OBRT to identify the fake reviews. To identify the fake reviews, so in an introduction, so the online reviews influence customers' decision in buying the product. So it's but the fake reviews are slightly increasing more because of large amount of data and AI generated content, it is very difficult to identify the fake reviews in a in a e-commerce. So we use a deep learning models to find the detection and accuracy manner. So we process the review data first. They select the important features using PSO, particle swarm optimization. So it simulates the social behavior of particles that learn from their own and group experience to find the best solution. Because the way of writing has been changing every year and passings. So based on that, the system itself improvises its learning process. So after that, we apply the different deep learning algorithms to detect the fake reviews more accurately. So the problem statement is, so the online product reviews strongly influences the customer buying decisions on e-commerce platforms. However, many fake reviews are posted by the fraud people to either promote or damage the product unfairly. So this reduces trust in online review systems and affects both customer and business. Therefore, there is a need for an effective method to detect fake reviews using advanced deep learning techniques and improve sentiment analysis accuracy. Why? Because by giving fake reviews, sometimes the genuine business people also will be affected by the reviews. So that's why it's an upcoming current social problem to identify the fake reviews. So the objectives that the main objective of the work are to understand the impact of fake reviews, study different deep learning models, and develop a system to detect. So finally, we evaluated a model using a standard performance metrics like accuracy and F1 scores. So data description, the data set consists of product reviews collected from e-commerce platforms. So each review includes different types of informations, and we use this data to analyze sentiment and identification fake reviews. The literature survey, the previous researchers have used various models like LSTM, DNN, deep neural networks, and BiLSTM for sentiment and fake review detections. However, these methods have limits such as high computational and difficult in handling long text. So improved deep learning models are needed for better accuracy and efficiency. So in the traditional, using the traditionals, so as the trending has been changes, we cannot able to identify the upcoming new trending patterns. So we need an deep learning models to identify the fake reviews. In the proposed, the research gap is the same thing. So it's a cost wise it's heavy, and long text reviews we cannot able to identify using the traditional methods. So we have moved on for the deep learning methods algorithms, various methods algorithms to identify the fake reviews. So in the proposed system, the system uses different types of deep learning models and transfer models to detect the fake reviews. So we have used the Kaggle data sets for testing, and after processing and feature selection, the system successfully identifies the fake reviews and improves the accuracy. So this is our architecture. So how the exactly the system works. So in the first, it will start with the fake review data sets containing it may contain some the one different types of data sets we have. Some data sets have ratings and fake reviews, and some will have only reviews. Like that, we will have a merged type of data sets. So here it starts with containing review category, rating, label, and text content. So first, the text data is cleaned by removing noise such as punctuation, special characters, and stop words. After pre-processing, the cleaned text is converted into a numerical form using the FTET algorithm. So fast text embedding data algorithm. Okay, using this we will capture the semantic relationship using the characters engram. Next, it will move on to the particle swarm optimization PSO. So here is applied to select the most relevant features, improving efficiency and reducing the irrelevant data. So here it will remove the is, was, that. So comma, full stop, it will be removed in the data pre-processing, and the text which is required for the processing, it will be entered into the feature selection. So the PSO will select the required features, exact features needed for the testing. so classification, then it will be move on to the deep learning algorithms. So after that, it will after the analyzation performance evaluations, so it will generate a classification whether the review is a fake review or an original review. So that will be the output. So first we have used various models. So in this first one is graph convolutional network. So here it treats the review as a graph and learns relationship between the user and the product. So this helps for detecting hidden fake review patterns. That means, for example, if I am purchasing a pen, so I want to give a review about the pen. So the customer purchasing pen and the content review content should be related to the pen. So it will maps whether it is exactly relevant the user as well as the product which he purchased and the review given by him. So it the three things should be related to each one. So that type of identification can be done using the GCN. The next one is hierarchical GAN. So it's a GAN as GAN. So generative adversarial network. So here, what it will do means it have a two models. It have a two models. One will generate a fake review, and another one will it generated review can be checked whether it is real or fact. So itself it generates fake reviews like features, and it detects whether it is a fake or not. So that two types of process will be done over here. So in the sentimental majority voting, this is a sentiment. So always some text command, it will hurt the persons as well as it will affect the business. So here the sentiment majority voting classifier, what it will do means it will take like a majority of votings, who like this, who not like this, like it will take a reviews and various models gives a. So here it will gives a three types of result: positive, negative, and a neutral. So based on the highly voting of positive or highly voting of negative, so the result will be given whether it is a fake review or a genuine review based on the majority of voting percentage. Either positive gives high means, so it will give it as an original review. So negative gives more result from the model means it will give it as a fake review. So in the convolutional neural network with bidirectional long short-term memory, so what it will do means the convolutional neural network, first it classifies the given text into n-grams. Okay, later that then bidirectional LSTM, it will analyze the data in forward direction as well as the backward direction to analyze the text, whether the given text is a original text or an fake review test. So it will both the direction it will analyze the reviews and give you a result whether it is a fake or not. So this is our transform is the proposed optimized bidirectional encoder representation from transformer. Here we have used an attention concept. So in the attention concept, what it will do means the attention concept, it helps to focus on the words in a sentence. For example, the product is not good. So not. So it's here the not is meaning so well so many things. So it will analyze the exact keywords which is necessary to analyze the whether it is an fake review or a true review. So in the result and discussion, so we have used 40,000 reviews, the data set. So it is in the ratio of 70 is to 30. That is 70
Excuse me.
is to 30 ratio. Okay.
I'm so sorry to interrupt. You have a minute left.
Okay, ma'am. Yeah, I will complete it. So based on that, we have got an accuracy that CNN and BLSTM has got an highest accuracy in the overall research. So challenges we have faced is we can use with the minimum data set. It will be helpful and it will give an accuracy. When we'll move on to a large data set, we will face so many problems, as well as if the data is uncertainty or incomplete also or noisy, we will face a problem. The future is that we can move on to the real world. Still we have used in the data sets. We can move on with the real world reviews data sets, as well as we can move on to the large data sets for entry. Thank you so much.
Yeah, thank you for the presentation. I want to ask, generally fake reviewers continuously evolve their strategies. So how robust is your
Yes,
model
ma'am.
against adverse? Hello, am I audible?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yeah. How robust is your model against adversarial or increasingly human-like reviews generated using advanced AI tools?
Yes, ma'am. Using linguistic, ma'am. So using linguistic analysis method, we can identify the AI generated. But here we are facing so many problems here, ma'am. Some of the AI is generating as like human written facts. So it's a critical problem rising over there to identify it, ma'am. But currently we have used the linguistic to identify the AI generated reviews, ma'am.
So is it supposed to have only English reviews, or you are going for the multilingual reviews?
No, ma'am. Just in the beginning we have used only the English reviews, ma'am.
Okay, what was the data set size?
40, ma'am. 40 reviews, ma'am. 40,000 reviews.
40?
40,000 reviews, ma'am.
40,000 reviews. So from where you have taken this review data set?
From the Goggle, ma'am. We have taken two types of data reviews, ma'am. One is from the product, electronic products, and one is from the Amazon M-Truck, ma'am.
I suggest you to go for the Flipkart also, right? Because
Yes, ma'am. Yes, ma'am.
yeah. I mean, whenever you will compare the Amazon reviews and Flipkart reviews, you will find many things over there. Secondly, I would also suggest to span your review type. You are only taking positive, neutral, and negative, right? So many of the papers, even they are extending their work for 7 categories, right? So extremely positive, then very positive, then I mean they span something like fuzzy, maybe taking 5 categories for reviewing this one, or categorizing this one, or 7 types. So for this you need to extend in some context, because many papers are working on this one also.
Yes, ma'am. We will try on the fuzzy set also, ma'am. Next, we will
Right.
move on to the next future work, ma'am. Thank
Okay,
you so
thank you.
much.
Yeah.
Hello.
Sir, good
I
afternoon,
have
sir.
one question. Hi, good
Hi,
afternoon.
yes,
I
sir.
have just one. Um, so this proposed overt model was considered superior, right? For fake review detection based on your result in discussion, as well as your conclusion. No. Again, how could you elaborate or the comparative performance of these models, especially for the different DL approaches, GCN, HGN, CNN, BLSTM, in terms of
So based on the
accuracy, precision,
yes, sir.
and recall?
Based on the accuracy only, we are comparing the various methods, sir. Already this data sets are labeled, sir. So
Okay.
we are taking a labeled data set, sir.
Okay. So for my recommendation for your future work, this maybe uh, I would like to back up my co-chair regarding the use of multilingual datasets in across different e-commerce platforms. So, well, this will demonstrate robustness and adaptability in diverse consumer markets in the future.
Oh, yes, sir, sure, sir. Uh, so we are trying to identify this, sir, because the using we are trusting the reviews. Mostly, we are purchasing products on the review based. So we will move on to future work, sir.
Okay, that would be all.
All right, so now we move on to the next presentation for today. And next up, we have Miroslav Czech, who will be presenting security and reliability aspects of FSO integration into private 5G networks. You may now begin your presentation.
Okay, give me a second. Can you hear me clearly?
Yes, we can.
Okay, and give me a second. And can you see my presentation?
Yes, we can.
All right, perfect. So, good day, everyone. My name is Miroslav Čech from Slovak University in University of Technology in Bratislava, and today I will present our work, which is focused on the security and reliability aspects of integrating free space optics, or FSO, into private 5G networks. So the motivation for this work comes from the increasing demands for high capacity, reliable communication in industrial and campus environments. In today's networking, we have a lot of new applications connected to automation, robotics, and we also have a lot more devices connecting to our networks. This means that the demands for our network infrastructure are constantly rising and require very low latency, high reliability, and strong security. To fulfill these needs, these networks require a reliable transport layer technology. Traditional transport layer technologies like fiber or RF links obviously have their place on the market, but they are not always optimal, which means there is space for alternative technologies such as free space optics. So basically, the goal of this work is to analyze different private 5G architectures and explore how FSO can be integrated into these different private 5G architectures, what would be its role in these networks, and how it impacts latency, reliability, and security. Before we start talking about FSO integration in 5G networks, we should discuss what it means to implement a 5G network and what different types of 5G networks can be implemented. Because the FSO integration depends on the architecture of a 5G network we want to implement it in. Private 5G networks are dedicated networks tailored for specific organizations. So there are multiple types of private 5G architectures, which differ in the amount of control the organization has over the network. These networks allow for control over network parameters such as data being sent over the network, the security policies implemented in the network, and quality of service parameters active in the network. All these parameters are under either full or partial control of the organization, depending on the chosen network architecture. The use cases for these types of networks are usually large industrial areas, campuses, or other critical systems. These are the different types of 5G private network architectures. So starting with SNPN. In SNPN, the enterprise or the organization owns the entire network, including the RAN and the 5G core. The network is fully private, which enables full control over security policies implemented in the network and data processing within the network. The network is completely isolated from public networks, which increases its security and predictability. The drawbacks of this are obviously the higher cost of this implementation and the need for more trained personnel to actually administer the network. In contrast, PNI NPN combines private and public elements. It offers a hybrid model where some parts of the network are shared between the public operator and the organization. PNI NPN provides easier deployment, but introduces dependency on public infrastructure and gives less network control to the organization itself. Depending on the deployment model chosen, the sharing could be implemented with radio access network, the shared RAN and the control plane, or even rely entirely on the operator who provides the network to the organization as a service. These models reduce implementation costs and complexity along with the need for trained personnel, but limit control and optimization. In terms of services that should be available in 5G networks, 5G supports three main service categories. These services define requirements which the network should be able to provide, such as high data rates in the case of eMBB, ultra-low latency and high reliability in the case of URLLC, or massive connectivity of a large number of devices in the case of MMTC. This is important because the transport layer must be able to support these requirements in order to keep up with the networking trends and provide a reliable communication infrastructure. And now for the FSO technology itself. FSO is a wireless optical communication technology that uses laser beams to transmit data through free space. It provides very high link capacity, very low latency, and inherent physical security due to the narrowness of the propagating beam. Unlike RF communications or radio frequency communications, it is difficult to intercept, which could make it attractive for secure applications. And because it is wireless, we do not need a massive cabling infrastructures such as in optical fiber solutions. Obviously, this technology also has its major drawbacks, mainly the sensitivity for atmospheric conditions, which arise from the fact that in order for this communication to function, we need a line of sight between the communicating devices at all times. The implementation of FSO in private 5G networks depends on the 5G model we wish to use. In the SNPN architecture, FSO can be deployed as a primary transport technology. Specifically, it could operate at the transport layer, connecting base stations, edge nodes, and the 5G core. This means that FSO links can replace or complement fiber connections between network segments. One of the key advantages is that the entire communication path remains under the control of the organization, which allows precise optimization of latency, quality of service, and security mechanisms. From a performance perspective, FSO can provide transmission speeds of tens of gigabits per second with very low latency, which makes it suitable for URLLC and eMBB services. Regarding reliability, one of the main challenges is the sensitivity to weather conditions. To mitigate this, we could use redundancy, for example, multiple FSO links or hybrid FSO RF optical fiber solutions. From a security point of view, FSO offers both physical layer security due to the narrowness of the beam and the standard 5G encryption. In PNI and PN architectures, the role of FSO would be slightly different. It would not be used as a fully independent transport layer, but rather as an interconnection between the private network and the public operator. In scenarios where the RAN is shared, FSO can connect private base stations to the operator's infrastructure. In this case, FSO would provide high-capacity transmission, but the overall performance depends partly on the public network, especially in terms of latency. Security would not be managed locally, but rather in the public 5G core. If both the RAN and the control plane are shared, FSO can connect to the local 5G core or user plane with the network elements, which reduces latency compared to full dependence on the operator and allows partial local data processing. In this scenario, FSO could be used as a high-capacity transport between private and public parts of the network. And in the most integrated scenario, where the network is provided as a service by the public operator, FSO can act mainly as an access transport technology between the customer and the operator. In this case, the network is logically separated, for example using network slicing, but physically it remains part of the operator's infrastructure. This introduces higher latency and less control, but it simplifies deployment. And from a security perspective, the system relies more on operator-managed mechanisms such as authentication and network slicing. In terms of FSO challenges, the most significant issue is obviously the atmospheric attenuation caused by fog, rain, turbulence, and other atmospheric effects. These conditions can obviously drastically degrade signal quality and reduce link availability. Another challenge is maintaining precise alignment between the transmitter and the receiver, which is caused due to the narrowness of the optical beam. Our future research will focus on addressing these issues, mainly by evaluating how artificial intelligence can be integrated into FSO systems, which includes investigating how AI could be used to predict channel conditions, dynamically adapt transmission parameters, and optimize link performance in real time. We will also analyze what aspects of the system could be controlled by AI, such as beam alignment, power control, or switching between redundant FSO and RF links. The work will include simulations as well as real-life measurements, and the goal would be to improve overall reliability, reduce latency, and enable more autonomous and intelligent optical communication systems. This is my acknowledgement for my work, and that is all for my side. Thank you all for your attention.
Yeah, hello. Yeah, my question is,
Yeah.
FSO links are highly sensitive to atmospheric conditions such as fog, rain, etc. So how does your system ensure reliability and continuity of service under such adverse conditions?
Yeah, so this work that we have done so far is just an analysis. We are currently building a system, a simulation model in MATLAB, along with a real-life laboratory where we have an FSO system available, and we would like to simulate in the simulation some of these atmospheric effects. Then compare the simulation to the actual real-life measurement to measure how accurate our model is. And then from there, we will examine supervised, unsupervised, and reinforced learning techniques, various techniques to apply to the simulation to see how it would react to these atmospheric conditions. And then we would transfer it to the real-life measurements to see how we could actually improve real-life FSO links.
Yeah, another question is how effective are hybrid communication systems in maintaining the network performance?
Based on several studies I have collected in also my work, my PDF, these hybrid systems are very reliable, very effective. The effectiveness is higher than 99.9%. Which basically the point is that when an FSO system goes down due to poor network conditions, it can switch to radio frequency and vice versa, which means this provides very high reliability, and this is something we want to also achieve.
Have you gone through some research works or have you implemented something for such cases?
We have not yet implemented any of these hybrid systems, but we are working on the simulation model and also the real life laboratory solution.
Okay, thank you.
Hi, hello, good afternoon. So I have just one question. Aside from the challenges of environmental disruptions, is this vulnerable to interception?
FSO systems are generally harder to intercept than radio frequency communication because FSO systems propagate a very narrow, very thin beam of light to communicate. So basically, if the attacker tries to intercept the communication, it would be very hard for him to intercept it and for the link also to function. Most likely, what would happen is that if he intercepts the beam in the middle between the transmitter and the receiver, the link would fail. So the operator would know exactly that okay, something is up, something crossed the beam, and the link is down. The other option for the attacker would be to maybe sit behind the receiver and try to catch the data beam from behind the receiver. But there are also ways to physically obstruct anyone from going near the receiver or the transmitter. So I would say it is less prone to interception than radio frequency networks, radio frequency communication.
Okay, thank you for that answer. Congratulations.
Thank you.
All right. So our next presentation will be by Tanmay Dey, who will be presenting Swift and Contactless Money in FinTech Industry, Understanding of Customer Loyalty Towards Unified Payments Interface. You may now begin your presentation.
Ma'am, excuse me, ma'am. My name is Sagar, ma'am.
Sagar,
Actually,
we
I
will
have,
have you after a few presentations, actually. We have
ma'am,
a few
actually,
people
I
waiting in
have
line.
classes in the afternoon. I will just complete in a few minutes, ma'am. Could you please allow me?
Okay, can we just check for a moment? We'll call you after this presentation then.
Okay.
I'm sorry, if Tanmay is present in the meeting, you may continue. All right, I believe Tanmay is not here. In that case, Lakshmi Sagar, you may continue with your presentation.
Can you see my screen now?
Yes, we can.
Yeah. So actually, our paper is a review on large language models in engineering. It is co-authored by Nitin Gattapagari and Praveen Kumar Sarayani, our faculty guides, and Lakshmi Sagar, myself, Reddy Lokesh Bhan Prakash, and my other friends. So this is the outline of our paper. We have covered only a few sections: introduction and the LLM's role in the engineering and the challenges faced during the LLM's integration, conclusion and references. First of all, let's start with the introduction. During the late 2022, we can see the LLM surge very rapidly. Like these LLMs are trained on vast data sets, and they have been implemented in almost every possible discipline. And why possibly engineering is only we take is most of the LLM's advantages are in the scope itself. Like we can see in the scope of this review, there are LLMs are mainly used in programming, problem solving, intelligent tutoring, technical writing, and simulation support. We will discuss detail in the next slides. And these are the some brief benefits and brief challenges faced in the LLM's advantages. In the benefit side, we have on-demand beyond classroom explanations. Like if you have a phone and internet, you can access the LLM and get your explanations. Self-paced trainings reduces the time spent. And on the other side, challenges, academic challenges, we can see there is a risk of passive knowledge consumption, hallucinations, traditional assessments become insufficient, and it constantly alters the line between the understanding and critical thinking. So in the main disciplines of LLMs, like in computer science, electrical engineering, mechanical and civil engineering. In computer science, most of the people deal with the code generation, debugging, and algorithm analysis. Obviously, we have seen rapid developments in that sector, because we can see GitHub Copilot, GPT 5.x, and Codex. Recently, Cloud Code. We have seen many surges in this computer science field. And coming to electrical engineering, in the concepts of Laplace Fourier transforms, control systems modeling, and circuit analysis, these LLMs provide a step-by-step derivations with assumptions it has assumed, and no other problems. Like it will give a step-by-step solution. And in mechanical engineering, during the dealing with thermodynamical cycles, entropy, fluid mechanics, and other, it can give a step-by-step solution, and including the computer automation design, and it can provide a step-by-step assistance. And talking about the civil engineering side, we can take about load distribution, strength of the materials, and these LLMs are designed to reduce the work done by the human, like the complex thinking. It reduces and gives step-by-step solution, gives detailed specific answer with formulas. And in the core domains where engineering mathematics supports as a backbone of engineering, we can see differential equations, linear algebra, probability statistics. These are the main in most of the engineering domains. And LLMs offer great explainability in rather than classrooms in this domains. And they can also bridge the gap between conceptuals and also support quizzes. And as an ML student, I opt to get deep knowledge about the algorithm before implementing the code. And also I can also ask follow-up questions like what should I do next? Like it can build the incremental thinking. You can get your concept building brick by brick. And then also it can, and as per the citation 28 we have mentioned in the paper, these computational thinking and programming, these students are improving. Like they can improve themselves and while chatting with the LLM. And these LLMs are used in technical writing and the documentation purposes, like in report writing, research assistance, grammar, clarity, and caption projects. During the documentation process, like or submitting your final reports, students mainly or heavily prefer to rely on the LLMs itself, because the project they have implemented is done with the AI itself. So they get a clear report of what they did and how they did and why they did. So so if we thought this is the line where AI can go, we might be wrong, because in the simulation and computational tools in MATLAB, like signal processing, we get the output. I'm not denying that, but how far our algorithm perform best is known, may not be known by us, but can be known by the AI. And ANSYS software, it is used in aerospace mainly. It uses finite element analysis, where we cannot, I mean, the LLMs gives the particular answer. Okay, your model is strengthened here, but it cannot do this. Like you can get a detailed report of your idea. And I in the citations we have mentioned, like GPT-4 has been integrated with Blender and give remarkable results. Like you can understand what was happening, why it is happening, and you can find the errors easily, and you can clear them rapidly. Yeah. And yes, obviously there will be some challenges while dealing with something best. And four main challenges we have faced in the LLMs is, first and foremost is hallucinations. Second one is over reliance on the AI tools. So we may not verify the LLM data. We just take it. We just take it. Once it gives, we just take it. We might not verify, and this promotes the hallucinations. It considers it as correct. Okay, I'm correct. I will keep on sharing this one, which is not encourageable. And over reliance on skill attention. If we get the answer in a very small steps, we might tend to procrastinate, or else our knowledge will be reduced, or like some kind of we will demotivate ourselves, like I can do this even if in a very small amount of time. And this can result in over reliance on those AI tools, and can reduce the human skills like critical thinking. And another two challenges we faced were academic integrity and ethical safety, professional ethical risk. First one is academic integrity. First of all, during the traditional assignment submissions, we can see that simply you can just upload the document. There is no issue in that. But after some time, the plagiarism is introduced, and after some time, uh, you teachers have set a benchmark, like the assignment submitted should be less than 25%. Then only we can give the full marks. Hopefully, there will not be a situation. It should be at least written by human. So in that cases, these challenges there. And ethical and professional risk. All engineering branches are affected by the public safety. Like some AI tools have been used by hackers or any others. In like there are no restrictions for some AI tools. You just ask, it gives. That's it. No limitations. And this can raise safety concerns, ethical reasons, and professional risk. And coming to the conclusion, students in the computer science use the LLMs in code support, debugging, and algorithm analysis. And from the code departments, they opt for problem solving. And uh, most students are belong to the intelligent tutoring because they want a step-by-step solution, because the classroom moves in a fixed pace, but they might not get the effective explanation. And some students even might experiment with the AI, like what happens if this case happens. They experiment with this AI, and they build their knowledge. And technical writing and document studies have shown significant grammar precision, structured documentation, etc. And simulation support in MATLAB, ANSYS, SolidWorks. Many of the simulation tools are also integrating AI to their simulation tools. And these are the references we have taken. And yes, thank you for giving me the opportunity.
Yeah, hello.
Yes, ma'am.
From a practical standpoint, how can LLMs be effectively integrated into existing engineering pipelines, such as CAD design, simulation, etc., without disrupting established verification and validation processes?
Ma'am, can I get the question again, ma'am? I didn't understand.
Yeah, sure. In case we see the practical standpoint of this LLM, so how LLM can be effectively integrated into engineering frameworks like CAD design, simulation, etc., without disrupting established verification or validation processes?
Ma'am, new approaches or else existing algorithms just with a small modification can improve better, ma'am. In that cases, the LLMs can whereas we students cannot see that because everything is new for us. But LLMs know the entire documentation, entire existing algorithms. They can they might just alter this particular parameter, or just one particular parameter. You can get a better result, but it might be same for many people. But seeking a professional expertise help, it can be more effective, ma'am.
Okay, thank you.
Hi, good afternoon.
Good
You
afternoon, sir.
mentioned one of the challenges, even on accuracy and hallucinations. So
Yes, sir.
even if incorrect, this might be the generated output might be accepted by the students.
Yes, sir.
So, do you have any idea now to mitigate this hallucination, especially in safety critical engineering tasks such as structural analysis or
Sir,
circuit design? Do you have any idea to mitigate this?
Yes, sir. So we have generally seen while using ChatGPT, if we ask a new question, it will give two responses based on which you pick. So it can be used as a feedback for the ChatGPT and for the training itself, sir. Like which should be more trusted, like which is more encouraged by the users. So it is on our hands also, sir, whether to verify the AI responses. If we opt for the hallucinated answer, we might get the model hallucinated, and we will we will be increasing the false information most of the time. And
Okay.
also with that, there are faculty in the institutions also, and students, after discussing with the AI, it is better to seek the professional help, sir. The teachers with the experience, they can give you the better approach, or else just modifying the slide parameters, they will give they will give their best compared to the AI.
Okay. That's one of my recommendations. So there should be a design in the curricula, right, to
Yes, sir.
encourage both combining AI assistance with the human-led
Yes, sir.
problem-solving exercises. Okay, that would be
Yes,
all. Congratulations.
yes, sir. Thank you, sir.
All right. Our next presentation for today will be by Dennis A. Dizon, who will be presenting software quality assessment of a lending automation system using ISO IEC 25010. Dennis, you may now begin.
Yes, ma'am. Am I now audible?
Yes, you are.
And can you see now my screen
Yes, we can.
for a while? I think I just need to turn on my video. Okay, now, to the organizers of ICTIS Thailand 2026, thank you for accepting our research study and for allowing us to present in this prestigious conference. My respect to our distinguished panelists, Professor Bobby A. Clarin and Dr. Shalini Puri. My name is Dennis Dison from Caraga State University, Butuan City, Philippines. Today, I will present our study on software quality assessment of a lending automation system using the ISO IEC 25010. Access to formal financial services remains limited in many developing regions. This is due to economic and infrastructural barriers. Lending institutions often rely on manual processes, leading to slow loan processing and high operational costs. This gap underscores the necessity for innovation in financial technology. Our research evaluates whether an automated lending system can address these issues while maintaining high software quality, providing insights into how such systems can enhance financial inclusion. The research objective is to evaluate the software quality of a lending automation system deployed in a financial institution in Butuan City, Philippines using the ISO IEC 25010 standard. And we focus on 5 characteristics, that is usability for ensuring that the system is user-friendly, and reliability for maintaining consistent performance without failures, while functional suitability is meeting the functional requirements effectively, and performance efficiency is operating efficiently under varying loads, and security is for protecting data and complying with regulations. For the methodology, a case study approach was utilized, offering a real-world evaluation of the system. This method allows for in-depth analysis of system performance and user interaction. For the data collection, we conducted usability surveys using System Usability Scale and UMUX Lite to gather user feedback. System performance was tested for CPU utilization, memory consumption, and inference latency, while security and data privacy compliance were assessed to ensure adherence to legal standards. For the participants, there are 10 system users, including loan officers and IT staff, participated in usability testing, providing critical insights into the system's real-world applicability. Usability research literature indicates that 5 to 10 participants can reveal the majority of usability issues. And the participants were expert users who interact with the system regularly, making their feedback highly relevant to operational use. The system employs a layered architecture. The application layer manages user interaction, and the data layer, which stores and manages loan records securely, while the processing layer handles data processing and feature extraction. And the machine learning layer utilizes a random forest model with isotonic calibration for predicting loan approval probability. Results in Table 1 show that the system usability mean of 82.5, indicating excellent usability and high user satisfaction, and a score higher than the system usability benchmark of 68 confirmed high user acceptance, while grade A overall rating indicates a highly acceptable system. In Table 2 result, the UMOX Lite instrument confirmed the system usability scale findings, with the evaluators rating the system as very useful and easy to use. This shows that users perceive the lending automation system as both effective and efficient in supporting lending and loan assessment activities. The system also achieved 99.5% uptime and complied with the Philippine Data Privacy Act of 2012 or the Republic Act number 10173 of the Philippines, and Open Worldwide Application Security Protocol, or the OWASP, Application Security Verification Standard Level 2 security controls, ensuring robust and security and data protection. Figure 1 shows the reliability diagram, and it confirms that after calibration, the probability estimates had vastly improved. The dashed diagonal line, the black line, where predicted probabilities are the same as the real-world outcomes, while the uncalibrated model, that's the blue line, it shows inconsistency and overconfident probabilities. This is indicated by its position slightly below the diagonal. The plot calibration, the sigmoid or the orange line, moves closer to the diagonal line, especially between the 0.3 and 0.7 probability range. And the green line, the isotonic calibration, produces a well-calibrated probabilities that aligns with the ideal diagonal line across nearly all probabilities. This proves that the system's reliability, as per ISO IEC 25010, is now ready for high-stakes financial decisions. And the isotonic regression configuration was chosen as the final deployable model for the automated loan assessment because it offers the best balance of accuracy and efficiency, and as it achieves a 3.11% improvement in probability calibration. For the conclusion, the lending automation system not only provides accurate predictive analytics, but also meets key software quality attributes essential for deployment in resource-constrained environments. And the ISO IEC 25010 framework facilitated a comprehensive evaluation of usability, reliability, performance, and security, demonstrating how automated lending systems can support financial inclusion while maintaining high software quality. That's all from my side. Thank you for your attention, and I look forward to the question and answer.
A good presentation, sir. I want to ask, in practical systems, quality attributes often conflict. For example, in case security versus usability. So, how did you handle such trade-offs in your evaluation, particularly in a financial application?
Usability and security, ma'am. Yes, that's correct. Yes. For the security, we enforces authentication checks and role-based access restrictions. That one, and the data were also anonymized and controlled access database. And yes, we also include Data Privacy Act. That's all of the personal identifiable information was anonymized, and data processing followed the RA 10173 of the Philippines compliance practices.
Okay. One more question from my side. Did your
Okay.
assessment incorporate feedback from end users or stakeholders, such as bank employees, and how did their perspectives influence the final quality evaluation?
Okay, for this research, ma'am, we only include only 5 to 10 participants because usability research literature indicates that those number of participants can reveal the majority of the usability issues, and those participants are also user experts who interacts with the system regularly. So it makes their feedback highly relevant to operational use. But for that, ma'am, maybe in the future study will include more participants, ma'am, especially the user feedbacks.
Okay. Okay, thank you.
Thank you, ma'am.
Hi. Hello, good afternoon, kabayan.
Hello, sir. Yes, sir. Hello, sir. Yeah, good
Okay,
afternoon.
you mentioned using the random forest model with
Yes, sir.
isotonic calibration, right?
Yes, sir.
This enhance the interpretability and reliability. So,
Yes.
can you further elaborate on how this calibration, isotonic calibration, improve the loan assessment outcome in
Yes, sir.
practice? Yeah.
Okay. Yes, sir. The probability calibrations, it ensures that the predicted probability of the loan defaults reflects the true likelihood of the event occurring. Okay, and this is important in lending because financial decisions depend not only on classification but also on accurate risk estimation.
Okay, so with that, because there are other ensemble methods like boosting and other algorithms. Okay, with
Yes,
that,
yes,
yes,
sir.
yes.
We selected the random forest, sir, because random forest performs well in a financial data set. It reduces overfitting through ensemble learning, and it provides an interpretable feature importance. And compared with the deep learning model, sir, random forest requires lower computational resources, which is suitable for deployment, especially in smaller lending institutions here in the Philippines. Yeah.
Okay. Just one more last question. How many systems did you uh, uh, evaluate?
How many systems? Sir,
Yeah,
for this,
yeah.
sir,
Loan
only one
systems.
lending institution, sir. You mean lending
Yes,
institutions?
yes. Mhm.
Yes, yes. We only evaluate yes, sir. One lending institution, sir, because we are focused on quality evaluation rather than comparison. Yeah, comparative results. Yeah, only one lending institution, sir. But again,
Okay.
in the future, we can evaluate multiple lending institutions, sir, for a
Yes.
more broader
For
result. Yeah.
okay, for comparison.
Yes,
Okay,
sir.
that would be all for me. Thank you.
Thank you. Thank you also, sir. Thank you also, everyone. Okay.
All right. Now, our next presentation for today will be by Neeta Dimle, who will be presenting Towards Transparent Cybersecurity, a survey of explainable AI techniques in intrusion detection systems. Neeta, you may now begin.
Good afternoon, everyone. Am I audible?
Yes, you are.
Okay. 1 second. So my topic of presentation is towards transparent cybersecurity, a survey of explainable AI techniques in intrusion detection system. So this is the agenda of my presentation. So this is the abstract. So the increasing complexity of cyber threats in cloud, IoT, and other network environments demand intelligent intrusion detection system. Actually, there are machine learning and deep learning improved detection system that improve the detection accuracy, but there is a lack of explainability, reduces transparency and trust. So this survey paper of explainable AI techniques for IDS and proposes a hybrid architecture that combines deep learning with interpretable models, explanation mechanisms. It addresses the challenges such as adversarial risk, scalability, and evaluation issues. The study emphasized the need of secure, transparent, and efficient IDS frameworks for modern cybersecurity applications. So this is the introduction. So the security tool called as a intrusion detection system that keep eye on system activity or network traffic. That is goal is to spot the activity, the policy infraction, unauthorized access. So basically in the intrusion detection system, there is a signature-based intrusion detection system and anomaly detection system is there. So in case of a signature-based IDS, it detects attacks by comparing traffic patterns to a database that is known attack signatures. And in case of this anomaly-based IDS, it finds the unusual network activity. It helps to uncover the emerging threats. So why IDS? The network faces so sophisticated zero-day attacks, anomalous traffic, and insider threats that rule-based system cannot catch. Then it comes to machine learning and deep learning models are there, like support vector machines, random forest, k-nearest neighbor, CNN, LSTM, and autoencoders are there to achieve 96 to 90% of accuracy by learning traffic patterns automatically. So it is beneficial, means it is pretty good to tell that what is happening in the network traffic. Then why we come to XAI? It is explainable AI. So it refers to a set of methods that help the people to understand the AI model, how it makes the decision, how the means how it explains when there is a threat or means some unauthorized activities goes in the network. So black box model lacks transparency analysis, cannot trust, audit, or comply with unexplained AI decisions in a high-stake environment. That's why this XAI is come into picture. So this is the motivation of study, as there is a rising cyber threats with the increasing number of cyber attacks. Traditional ideas struggle to misdetect that threat effectively. AI-driven ideas can significantly improve security. The lack of transparency in AI models. Deep learning models using IDS function as black boxes, making it difficult to understand why a network activity is a flag as an attack. So XAI can bridge this gap. Third is encrypted payloads. Encryption reduces DPI's ability to inspect traffic effectively. So next is the need of trustworthy AI in cybersecurity. Organization requires transparent and interpretable AI solutions to confidently rely on machine learning for intrusion detection, and advancing research in explainable AI for IDS. Combining XAI with IDS is not only enhances the model performance, but also contributes to the growing field of trustworthy AI in cybersecurity. These are the objective of study. To conduct a comprehensive survey of XAI techniques used in IDS, analyzing their strength, limitation, and applicability in cybersecurity, to evaluate and compare the existing XAI-based IDS models in terms of interpretability, accuracy, scalability, and computational efficiency. To propose a novel XAI-driven IDS that enhances threat detection while maintaining transparency and trustworthiness, and to validate the proposed XAI IDS by comparing its performance with existing state state-of-art ideas in terms of detection accuracy, false positive, and explanative matrix, and introduce a reference architecture combining deep learning, interpretable models, exponential fusion, and adversarial defense. This is the taxonomy for XAI techniques in ideas. First is the future attribution. So in future attribution, mostly it is uses sharp and lime, which is XAI techniques. That is sharp means sharply additive explanation that shapely values means it is properly feature based. It extracts the features from the traits. It predicts values from the given features. So shapely values from cooperative game theory, and lime, it is local surrogate model around each prediction, and random forest and gradient boosting per feature importance scores. Next is intrinsically interpretable. Decision tree rule-based classifier and linear models are used in that. Third is surrogate and model agnostic. Global surrogate, which is decision trees mimicking DNA and behavior. Model agnostic work with any classifier architecture, and fidelity of surrogate is critical for trustworthiness. Counterfactual explanation shows minimal feature changes to a flip prediction, reveals exact triggers of an intrusion alert, and it's forensic investigation of security incident. Gradient-based deep learning, that is saliency maps and integrated gradients for neural networks, attention mechanism in transformer LSTM-based ideas, and reveals temporal patterns in sequential network flow. This is the literature review that I have made for this. In year 2024, Malapatti that methodology and technique use post-hoc XAI techniques that apply to ML-based ideas frameworks. Key contribution is comprehensive analysis of XAI transparency techniques for ideas, evaluate how sharp and lime improve analyze trust, but does not address the real-time explanation generates. Second is Alabadi and Bajaber. It is sponsor is gives the methodology or technique is XAI applied to IoT data stream using SHAP-based feature attribution integrated with the streaming ideas pipeline. Key contribution is first to apply explainable AI directly to IoT data stream for ideas. Limitations limited and it is limited data. It has a limited data set diversity, computational overhead not fully quantified for low power edge devices. Paulicki and causes that do the survey on dual nature XAI challenges, which identifies the dual nature of XAI in ideas, simultaneously enabling transparency and introducing new security risks. And its disadvantage is primarily theoretical analysis, and which is limited empirical benchmarking. Khan Ahmed and Alani, which gives review on XAI-based ideas for Industry 5.0 and which proposes a taxonomy of XAI evaluation metrics specified to ideas. And evaluation, the limitation is evaluation metrics proposed are not standardized or adopted. In year 2005, Mohammed and this designer technique that line-based XAI that integrated with deep learning ideas, which proposes XAI ideas as a modular plug-in explanatory layer for any ideas architecture. But Lime, this explanation are locally inconsistent across the similar features. Next is Chandre, Bhujbal, and Zada, which give the techniques or methodology that interpretable ML techniques that review and applied to phishing attack detection, which demonstrate XAI applicability beyond network intrusion to phishing detection. Which has a limitation. Domain specific to phishing does not generalize finding to broader ideas concept. Mishra and Roy, which gives the methodology that comprehensive review of XAI for cybersecurity, which covers sharp and lime counterfactual and attention mechanism, which gives up-to-date survey of XAI in cybersecurity beyond ideas, but it is limited to broad scope, reduces depth in idea-specific analysis. Again, Chandre and Mahalle and Shinde, which gives review of XAI techniques for intrusion prevention system, which gives from comprehensive mapping of XAI techniques to specific ideas and limitations. It is just a review based. Then next, Marker, it gives counterfactual XAI applied to ideas, which demonstrate counterfactual explanation, improved for forensic investigation quality in ideas, and which is limited to computationally expensive to generate counterfactuals for high throughput traffic. Next is Zhang Li and Chain, which gives lightweight XAI framework for edge-based ideas in IoT, which proposes first hardware-aware lightweight XAI framework specifically, and accuracy explainability trade-off which is increased at very low. Then Al-Daweri and Al-Harbi.
I'm so sorry to interrupt. You have about a minute left.
Okay. This is my summary table actually. This is a data set and the detection model which is used with XAI techniques. Means by combining random forest and SHAP with NSL KDD data set, explanation type which gives global and local, 98.2 accuracy, CI/CIDS, Lime plus LSTM, which gives 97.5 accuracy, KDD, which gives 96.1 percent accuracy, UNSW NB15, which gives 98.7 by using CNN and integrated gradients. It gives 98.7% accuracy, and with the dataset CICIDS 2018, which use encoder that is used in encoder and SHAP, which gives 97.9 accuracy. So these are the challenges in applying XAI to ideas. High dimensional data, that network traffic has hundreds of features. So it is major challenge. So real-time latency, post-hoc methods are computationally expensive. Real-time latency is challenge for this. Then resource constraint, edge device sensors and cloud nodes have limited CPU memory. Then adversarial manipulation, attackers can craft inputs that produce misleading explanation. Accuracy and explainability, high accuracy deep networks require external explanation models that may reduce stability. No evaluation standard. Unlike accuracy metrics, there is no universal measure for explanation quality. And this is my proposed XAI IDS architecture. So these are the different layers. So first is a wireless sensor nodes. Here is means all the data is going to capture over here. Then this captured data is go to the deep packet inspection that is used. Basically, this deep packet inspection, it is used for the multi-level packet analysis, including protocol flow-based header analysis, payload signature. Then this payload signature that is which is used to extraction engine that applies pattern matching and regular expression based scanning to detect malicious signature. Then this all data is good for the pre-processing, means for undergoes cleaning, normalization, and for the data balancing. In that, for class balancing, SMOT and DSN is used. And after that, it is go for XAI driven feature selection and optimization. In that, all the features, and depending on that features, the features are getting ranked. Then it is that input is provided to hybrid detection engine. In that, invincible learning and counterfactual analyzer is used. And after that, this intrusion after that, this intrusion response and alert system generate the alerts, means low, minimum, or high. And
Excuse me, ma'am, I'm so sorry to interrupt. You've gone over time and
okay,
time is up.
Yeah, I want to ask, unlike accuracy, explainability is harder to quantify. So what evaluation matrices or frameworks do you recommend to assess the quality and usefulness of explanation in IDS?
Explanation means to evaluation matrix.
Yeah, just I mean, apart from this accuracy, what evaluation matrix do you recommend to assess the quality?
Means interpretability, stability, scalability. This I want to means this kind of accuracy matrices I will use.
Interpretability is already there in XAI, so you need to, to implement some methods or methodologies to get the interpretability of your systems
Yes,
or
actually,
system
ma'am,
components?
DPI is used for deep packet inspection. In previous research, there is only XA and IDS techniques are there. So, in this case, I have just added DPI and some some ensemble learning plus other CNN, RNN modules. So we get this better result than previous models.
So, are you planning to do statistical significance testing for the same?
Yes, ma'am. I'm planning, but no, means just this is the survey I have done and proposed the model. So I'm planning for that.
Okay.
Hi. Just one question on the proposed hybrid. It was cut off due to overtime, but I just want to hear if, because in your architecture, it integrates ensemble learning with a counterfactual analyzer. So how do you ensure that this ensemble's predictive accuracy aligns with the interpretability provided by counterfactuals, especially in complex multi-stage attacks?
So counter
Okay,
attack.
okay, yes, yes.
So by using end-to-end validations in that, this input IDS model, then XAI, then counter attack analyzer.
Okay, that would be all for me. Thank you.
Thanks.
All right. So now we'll be moving on to our last presentation for today. We will now have Ravina Osier Sibayan, who will be presenting Leveraging AI for Customer Insights in Oman Digital Market. You may now begin your presentation.
Good afternoon. Is my screen visible?
Yes, yes.
Yes, it is.
All right. Thank you. Good afternoon or good evening to everyone, and thank you for for a chance to present my presentations, and thank you for the panelists that was with us. So this is our research title. Okay, I'll just need to show it. Sorry, to make it screen show. Why it's not sharing? Sorry. Is that okay now? Is it?
We can see your PowerPoint window, but your presentation is not full screen.
Yeah, because it is in a, actually I'm playing in a full screen. So anyway, I'll just try to reshare again.
It would be helpful if you would share your entire screen.
Yeah. Is it showing now?
Yes, yes, Dr. Sibayan.
All right. Thank you very much again. So now I just want to to inform everyone that this presentation is already a second phase of our research project. One of the presenters, which is Dr. Cordova, already presented the phase one of our research. So good afternoon, and I am Dr. Rana from Gulf College, Oman. Now, the focus of our research is actually how the business can move from simply collecting data to making a smarter and decision driven. So these are the problems and research gap that we have found out. Okay, so and the focus is in the Oman context. So Oman businesses are generating massive customers data, but most of it are actually underutilized or not fully leveraged. So because of this rapid digital growth in Oman and the different language or multilingual interaction, so it will be difficult for the businesses to give their what you say competitive marketing strategy. Okay, so the research gap that we found out is there are existing tools. Okay, everybody are using their WhatsApp or website, for example, or any social media in terms of marketing, but these tools are fragmented, and of course, when you are going to combine, it will become technically complex, and the limitation is about the cultural adaptation. And although AI, I mean WhatsApp or other tools or other social media, there are AI, but we wanted the focus of this one is we wanted to have a focus, to have an integration of one AI driven solution tailored for Oman context. Then this is the central focus. I mean, this research central question that we have come out. To what extent that an AI integrated driven pipeline improve marketing performance in multilingual environment like the Oman. Sorry for the added letter C. Okay. So the research objective is to develop an AI-driven customer insight pipeline to compare with the traditional marketing approaches that currently are going on, and to translate this insight into a more actionable decision making. So here we try to address those objectives or to come up with that. And the key innovation here is not only the individual components, but they are integrated into single decision making pipeline. And that's why the approach now of our team is to come up with an AI driven pipeline wherein it composed of different layers. So of course we have the sources of data, whether it is coming from the emails, WhatsApp, or from their website, comments. Okay. So in this pipeline, we will try to clean the data in terms of preparation and in standardizations of the data that has been collected. And then we try to balance identifying to identify who are the customers are, especially those different what you call that for the minority group, for examples. And then we have we have integrated the model in terms of sentiment analysis to capture how they feel in terms of their emotions regarding to their reviews, for example. And then based on that model, it will provide now recommendations to the business owners or to the marketing people on what are the appropriate or effective way of to market their products or business. Okay, so here instead the strength here is the integration, and instead of treating the spare tools a separate tool, sorry, we connect them into a single decision making. Again, the purpose of the pipeline is from the data to the decision, integrating behaviors, sentiment, and action. Now, the study design. So we did some data collection. This data were collected from the businesses. No, we did not collect it anywhere, but we went to different types sectors to come up with these customers pay for experimentation. And we use the A/B testing and then statistical validation to okay to identify to ensure that our findings are reliable. So we have one year of the collected campaign activity, and we only use the two languages, the Arabic and the English language for this research project. Now, the evaluation metrics that we have used is in order to measure the proposed system for the business impact is the conversion, wherein we whether the whether I mean this is the customer's action taken, and then the retention, whether they are stayed engaged, the churn, whether they will drop off or they will not be engaged anymore with marketing, and then the return of marketing spend. Okay,
Excuse
so
me. I'm sorry to
yes,
interrupt. You have a minute left.
all right. So the objective of this is to find out the overall cost efficiency, right? So these are the results. As you can see, the AI versus traditional campaigns outperformed traditional across the matrix. Okay, so the customer insight, we have different. We found out the the four segmentation customers. So we have the high value, the engaged prospect, and based on that findings, we found out that the total of 55 is the overall sentiment score, wherein the insight is combined the behavior in emotion of to better target the customers. Okay, so this is our objective actually is to improve the targeting, to optimize resource allocations, and to personalized messaging. Scalability, since it is only on the context of Oman, so we are trying to scale that into Gulf region, for example. Okay, so of course that will be our next phase. So this in the conclusion, so we have we have identified four customer segments and the overall weighted of 0.55, and we believe that based on the data that we have collected in the prototype that we have developed, it returned to a 3 times return on marketing spend. For our future work, which is in the phase three is the real world deployment. Okay, so we already have the simulated prototype. I mean, we have already the prototype system, but we need to deploy that, and of course to expand the data set because we already have 450 that we have, which is we believe that it's not really enough to validate that, and of course to enhance the multi modeling. And then the other one is the system integration, which is you have to find out what are the challenges that they are going to face from the system that they are using, from the developer, from the marketer, for example. So this will be part of our future work and the longitudinal evaluation. Okay. So this, so hopefully phase three, this is now our deployment that we're going to do. Okay, so this project is supported by the Ministry of Higher Education and Research Innovations in collaboration of Gulf College. Thank you very much for the time.
Did the chairs have any questions?
Hi, hello. Good afternoon.
Good afternoon, sir.
Good afternoon, Doctor. Just one thing, though, because as we all know, Oman's digital marketing ecosystem involves
Yes.
sensitive customer data. So, how
Yes.
does your AI framework ensure compliance with local data protection regulations.
Okay, so just like what we have done now, we collected the data. No, our system, the prototype that we are going to make is the local. I mean, the Oman data protection must be integrated normally by system privacy by design. Okay, so all the data will be collected and only relevant people can access those information, just like what we have done in our simulation. We clean and then we remove the identity of the people, and we cannot share it to the people to other, because that is under the agreement also of Mohere and the government and Gulf College policy. So we ensure that the security and the data privacy are being integrated with that AI.
Okay, next question. Is the data set out of the 450 businesses, right? What
Yes,
particular industries you
we have
have
collected.
you have collected?
Okay, so we
Or this
selected the.
multi-industry? Okay. Go
Yes, it's
ahead.
a multi-industry. So we have one from the hotel, we have one from the tourism industry, and we have the e-commerce businesses in Oman, and also with what we call that. Normally, it's the e-commerce, the one that I believe it's the e-commerce. We have also from the reviews from the hospitals that we have collected. So
Okay.
tourism, the hospitals,
Tourism.
and the e-commerce businesses.
Okay, this is because I want to emphasize on this one, multi industries, because this would generate more precise insights tailored
Yes.
to the country's economic priorities. Okay,
Yes,
thank
sir.
you. That would be all.
Thank you, sir.
Yeah, hello. I have a question.
Yes, yes, ma'am.
Yeah. How does your approach balance personalized marketing with compliance to data protection regulations and ethical considerations?
Sorry, ma'am.
Yeah, my question is, how does your approach balance personalized marketing with compliance to data protection regulations and ethical considerations?
Okay. So as I have mentioned, as I have mentioned, we are not going to dispose, although I mean to disclose all the information that we are going to do. So first, that we ensure that the data that is being collected, the one that we have done in our prototype, before the decision has been done, so we clean all the data that are necessary. So we are ensuring that we remove the information related to a person data, and then when it comes to a marketing, like to personalize their marketing strategy, it depends now on the business policy. I mean, the business itself. As long as our data is promoting the data privacy, the AI will not collect all will collect, but they will balance it. They will try to remove it in terms of how the data can be disposed. So at the end, it's only under the business sectors, the business owner are be the one responsible of doing the recommended action.
Okay, thank you so much.
Thank you.
All right, so with that, we've come to the end of our session. I sincerely thank all of our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope the session was informative for everyone, and on behalf of the entire team, I thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters would be receiving their digital certificates through email within the next 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Just before we end, I would like to thank our session chairs, Dr. Shalini Puri and Professor Bobby Eclairin, for chairing this session. And on behalf of Team ICTIS and Global Knowledge Research Foundation and partners, I present to you a certificate and a token of our appreciation. Thank you so much for your valuable presence. Before we leave, I would like to request everyone to please turn on their cameras for a quick virtual snapshot. All right. Thank you so much, everyone. The session is adjourned. You may now leave.